Welcome back to the quick introduction to Python 3 for AWS Automation Engineers course. Today's video will demonstrate how to test various AWS services such as S3 and Lambda using LocalStack and Python Boto3 library on your local machine. Check out the supporting blog article to see examples of working with Amazon DynamoDB and KMS services. To repeat our examples, you'll need Python 3 interpreter, PIP package manager, AWS CLI tools, Boto3 module, Docker, LocalStack CLI, and IDE. We'll be using Cloud 9 IDE in this video, but you can use your local IDE such as Visual Studio Code, IntelliJ IDEA, or even a text editor. LocalStack is a tool that helps developers simulate the AWS cloud environment locally. It provides a way to create and manage AWS resources such as S3 buckets and DynamoDB tables without needing an internet connection or a real AWS account. This can be extremely helpful when developing applications that use AWS services, as it allows developers to test their code without incurring costs. LocalStack also includes features that make it easy to set up and use, such as an interactive CLI and a web UI. In addition, LocalStack is open source and free to use, making it an attractive option for developers looking to test their code against AWS services. Currently, LocalStack supports many AWS services, like AWS S3, API Gateway, SQS, SNS, Lambda functions, and many others. Check its official documentation for the comprehensive list of services supported by LocalStack. LocalStack also offers paid Pro and Enterprise versions. The paid versions of LocalStack support additional AWS services APIs and advanced features such as Lambda layers and web UI. In this video, we will use LocalStack Community Edition. LocalStack provides a few ways of getting started and deploying AWS services locally. LocalStack CLI Docker Compose Helm. Installing LocalStack Command Line Interface (CLI) is the easiest way to install LocalStack on a local machine and get started with the LocalStack. To install LocalStack, we will use Python's package manager (pip). Once installation is complete, you can verify the installation of LocalStack. LocalStack comes with integration with several tools and CLIs. Check out its official documentation to get the complete list of supported integrations. In this video, we will use AWS Command Line Interface (CLI) and AWS CDK Cloud Development Kit integrations. When you start the LocalStack service on your system, it uses a Docker container to run the different AWS services locally. And LocalStack exposes the APIs for these services on port 4566 by default. We need to configure this default port as an environment variable to use in our scripts and connect to the LocalStack Docker container using AWS CLI or AWS CDK. If you are a Mac or Linux user, open Terminal, execute the first command, and restart the terminal to apply changes. If you are using Windows, open PowerShell, run the second command, and restart the PowerShell. These commands will configure the environment variable LocalStack endpoint URL, and you can refer to this variable without explicitly mentioning its value repeatedly. To have the ability to use AWS CLI, you need to configure a separate profile named LocalStack. Please ensure that you've set up AWS Access Key ID and AWS Secret Access Key values to test. This step is required to make pre-signed URLs for S3 buckets work. Verify LocalStack configuration to ensure that the AWS CLI command for listing the S3 bucket executes without any errors. It is important to use the endpoint URL equal to the value of the LocalStack endpoint URL environment variable to send the AWS CLI API calls to the local LocalStack Docker container instead of AWS Cloud Infrastructure. To simplify AWS CLI commands execution, we propose you create an alias for the AWS command called AWS ls, for example. Apply the alias definition to your Linux or Windows PowerShell terminal. Now, you can interact with the various AWS services emulated by the LocalStack on your local machine. To test it, let's create an S3 bucket using AWS CLI in LocalStack. Use provided AWS LS alias to create a test S3 bucket. After that, use the AWS LS alias to list available S3 buckets. If everything works without errors, you're ready to go. We will be using the Python Boto3 library to interact with the LocalStack emulated AWS APIs and manage AWS services locally. The Boto3 library provides you with a low-level API client to manage AWS APIs. The client allows you to access the low-level API data. For example, you can get access to API response data in JSON format. In this example, we're configuring the Boto3 library default session to use the LocalStack AWS CLI profile and adding the endpoint URL to the Boto3 S3 client to point it to the LocalStack Docker container. The Boto3 resource allows you to use LocalStack AWS services in a higher-level object-oriented way. For more information on the topic, check out the quick intro to Boto3 clients and resources video. Similar to the Boto3 client, you can instantiate the Boto3 resource to interact with LocalStack APIs. To work with LocalStack S3 services, you need to use the Boto3 library S3 client and AWS CLI configured to interact with the LocalStack on the local machine. As the community version of the LocalStack version does not offer the user interface to interact with AWS services, you will need to use AWS CLI to verify the resources deployed in LocalStack. To create the S3 bucket in LocalStack using the Boto3 library, you need to use the createBucket method of the Boto3 client or resource. In our example, the createBucket method from the Boto3 client takes the bucket name as an argument. For more information about working with Amazon S3 using the Boto3 library, check out the Working with AWS S3 using Boto3 and Python video. To verify the bucket creation, we will use the LocalStack configured AWS CLI. To list the S3 buckets, you need to use either the listBuckets method of the Boto3 client or the all method of the Boto3 S3 resource. In our example, we use the all method from the Boto3 resource that returns an iterator object containing all S3 buckets. To upload a file to the S3 bucket, you need to use the upload file method from the Boto3 library. The upload file method allows you to upload a file from the file system to the S3 bucket. Additionally, the Boto3 library has the upload file object method to upload a binary file object to the bucket. Required arguments for the upload file method are the file name, the destination bucket name, and the target object name. In our example, inside the upload file method, we're using the OS module to get the file base name from the file path and calling the S3 client's upload file method to upload the file. To verify the upload operation, you can use the AWS CLI. Execute the following command in the terminal. To download a file from the S3 bucket to your local file system, you can use the download file method from the Boto3 library. Required arguments for this method are the file name, source bucket name, and S3 object name. Before deleting an S3 bucket, we have to ensure it does not contain any existing objects. First, let's define all required modules, variables, logger, S3 client, and S3 resource. To remove all the existing objects from the S3 bucket, you need to use the delete method from the Boto3 resource library. To delete an S3 bucket, you can use the deleteBucket method from the Boto3 client. The required argument for this method is the bucket name. Before calling the deleteBucket method, we're calling the previously defined emptyBucket method to clean up the S3 bucket. Now you can call everything from the single main method if you'd like. Amazon Web Services, AWS Lambda is a service for developers who want to host and run their code without setting up and managing servers. Utilizing the power of the AWS cloud, Lambda functions provide a simple API with which you can upload your code and create functions that respond to events and requests. We will explore the Lambda service in the following sections and learn how to upload and test your serverless application using the LocalStack on your local machine. we will use the Python PyTest module to invoke and test the Lambda function. You need to install the PyTest module before running the tests against Lambdas. To install PyTest, execute a regular pip command, pip install PyTest. Let's begin with the Lambda function code. Upon invocation, this function returns a simple JSON formatted response. Now, let's define several methods for working with the AWS Lambda service in the main utils file. Here's the required definition of imports, common variables, Boto3 session, and logger. The getBoto3 client method will help us reuse the code for instantiating the Boto3 Lambda client pointing to the local stack. The createLambdaZip method will help us to prepare Lambda deployment zip archive. The createLambda method is responsible for Lambda function deployment. To delete Lambda function, we'll use another helper method called deleteLambda. Finally, let's define the invokeLambda method responsible for the deployed Lambda function invocation. This method invokes Lambda function and returns the data, or the payload, returned by the Lambda function. Now, we're ready to define test case for AWS Lambda. The test case deploys Lambda function, then invokes it, checks that the return message from the Lambda function equals hello user, and finally, deletes Lambda function. Now, if you run the test case using PyTest, you will see similar output. Now, it's a good time to extend the previous example and demonstrate how to test several AWS services interacting with each other. Let's test the Lambda function code which saves the file to the S3 bucket. The code is straightforward. The Lambda handler method instantiates the S3 client, uses the putObject method to save the file to S3, and returns a JSON message in response to the invocation request. Now, let's make some changes to our main utils file. Imports, common variables, and Boto default session setup method remain unchanged. We'll add the Boto3 resource setup method to simplify S3 operations in methods we'll share in a moment. We added support for key-named arguments to the createLambda method to have the ability to pass them to the create function Boto3 client method. We'll use this feature when we'll deploy Lambda code to the local stack with additional environment variables. The deleteLambda method remains unchanged. The Lambda invocation method will stay untouched too. Now, we start showing new methods. The first one will be the createBucket method responsible for S3 bucket creation. The S3 upload file method is helpful to create or upload a file with specific text content to the S3 bucket. The list S3 bucket objects method returns a list of S3 bucket objects keys. We'll use this method in the test case. And finally, the deleteBucket method cleans up the S3 bucket and deletes it afterward. Now, let's take a look at the test case. This test case is simple but powerful. We're deploying the Lambda function with a specific environment variable to let it know that the code is executed in the LocalStack environment. The code of the Lambda function will use the LocalStack environment variable to adjust Boto3 client settings. After the Lambda function, we deploy the S3 bucket. As soon as the Lambda function and S3 buckets are deployed, we can invoke the Lambda function, and it will upload the file to the S3 bucket. We query a list of S3 objects and compare it with well-known file names in the test. The test passes if compared lists are equal. Finally, we destroy the Lambda function and S3 bucket. Execute the PyTest command to see test results. That's all we wanted to cover in this video. For more information about this topic, please check out the official LocalStack, AWS, and Boto3 documentation. These resources are the most up-to-date sources of information. Please let us know in the comments section below if you'd like more information about specific use cases of working with LocalStack or any other AWS services using Python and the Boto3 library. Don't forget to subscribe to our channel and press the like button. This will help us to publish and spread more educational hands-on content related to cloud automation for the community. Thank you for your attention and stay tuned.